So we've been talking about log word problems, and you did some log word problems last night for homework. And let's just kind of look at a little bit of review here. We see that y equals 10 to the x. If we look at this over here, we can see that y equals 10 to the x is the inverse of y equals log base 10 of x. And we did talk about a log being an inverse of an exponential. Now we have a different type of exponential that we're also going to be talking about today, and that would be y equals e to the x. Now, if you take your calculator and you will see that there's an E button, it's second ln on the left-hand side there, about halfway down, and then you raise that to the first power, you'll see that E is going to be 2.7, and then it goes on and on and on, 1/8, so on and so on. So E really is a number. It's just not a whole number, whereas over here on the left-hand side, the base number is 10, and 10 is a whole number. So sometimes we're going to have word problems very similar to our log word problems, but instead of having a base that's a whole number or a base that's 10 or 12 or whatever the case may be, we're going to have a base with E. So E also has an inverse, and its inverse is called, we say, the ln of x. Okay, the ln of x. And these guys, just like over here on the left, y equals 10 to the x is the inverse of y equals log base 10 of x. These guys are also inverses of each other. And I'll show you how this applies to some of the word problems. All right, so this is a problem that we had been working on yesterday. I'm just going to do a real quick review of this. So let's say we have this formula, and we are depreciating. We're going to have a car that's worth $10,000 initially. It depreciates 5%, let's say annually, and let's say we are asking for how long till that car is worth $7,000. So since it's a depreciation, we're going to have a subtraction of the rate and then to the t power. So just like we did yesterday, we're going to put in our original amount. Usually always goes to the right of the C, so that would be $10,000 will go here. Okay, oh, this is going to be a real squeeze. There we go. $7,000 goes there on the left, and then 1 minus, remember to take your rate and always change it to a decimal, so 0.05 and to the t power. So as we did yesterday, you're going to divide out that 10,000 to both sides, which will give you 0.7 equals, and then we're going to have 0.95 to the t. Okay, now here's where it becomes important when we're comparing a log word problem to an E or an ln word problem. Since my base, which is 0.95, is not an E, then what we have done up to this point, remember, is in order to get a power down, we apply the power rule and we log both the bases. So we're going to log this 0.7. And then on the right side, we're going to write t times the log of 0.95. And then just remember we divide everything by log 0.95, and our time will be 6.9536. So if I was rounding that to the nearest year, we would technically say 7 years. Okay, so that is how we would do a question involving a log word problem. Now, you're going to be getting a worksheet, so I would like you to pause me for a second, get that worksheet, and then we're going to do number 1 together, and I'll show you how we can compare a log word problem to an E or ln word problem. All right, so if you look at the worksheet, you can read that top on your own. But I want to look at number 1, which is right underneath all the little notes there. And it gives you a formula, just like our one right over here that I'm boxing off. Okay, it gives you y equals c e to the kt. Okay, so as soon as you see that e, that's when we're going to do something just very slightly different. So if we read the question, it says a growth of a population is modeled by that equation, k is a constant, and y of t, in this case y, is the population size at any time t measured in years. All right, here we go. If this population doubles every 12 years. Now, they don't give you what the original population is. You can make that up. You can give it a value, any value you want. I'm going to go with 10. So if we start with a population of 10 and it doubles every 12 years, then it would make sense that our y would be 20. Now, if somebody else wants to make that c value 100, then their y value will be 200. If you want to make your c value 5 and then your y value would be 10, you'll see it's not going to matter, and I'll show you in just a second. So then we have e to the, now they're asking you to find k, and they say that the population doubles every 12 years, so our time is going to be 12. Okay? All right. Now, just like over on the left where we divided everything by 10,000, we are going to divide everything here by 10. You're getting that e by itself. So we divide this out and we get 2 equals e, and I'm just going to switch that around because that looks a little prettier, to the 12k power. So this is where I want you to just be careful and look at this. Compare this. Oops, that didn't work too well, did it? There we go. Compare. Oh my goodness, there we go. These two steps right here. We're in the same exact spot. However, on the left, because our base is 0.95, we logged. Because our base is e, the only difference is we're going to ln instead of log. So instead of writing log 2, I'm going to write ln 2. I'm still going to bring that 12k down because it is an exponent. And by laws of logs, and ln is just a natural log is what they call it, we would do the same thing. So we bring that 12k down in front, and then we write ln of e. Okay? And just like we do before, we would divide both sides, in this case by the ln of e, the ln of e. And Trevor, if you're paying attention, remember he came up with something like, oh, log 10, how come it ends up being the same? Well, guess what? The ln of e, that ends up being 1 as well. So when you do the ln of 2 divided by the ln of e, you're just going to get whatever the ln of 2 value is. Okay? So for future reference, you don't need to worry about putting ln of e in your calculator because they will cancel out and become a 1. All right. So then, basically, all we're going to be getting here then is the ln of 2, or whatever the decimal equivalent is. It's up to you how you want to write that. And then all we're going to do is we're going to divide everything by 12 here, and then our k value will be 0.05776. Now all you need to do is look at your multiple choice answers, and you will see that it's choice A. Okay? So that's basically how we work it out. So if you see an equation that's given to you and there is no e in it, then you log both the bases. If you see an equation that's given to you and you do see an e in it, you're just going to ln both the bases. Okay? And again, remember on your calculator, the ln button is right below the log button. So when you have an e, hit the ln. When you have not an e, you hit the log. All right?